Assalamu alaikum, dear students. Our today's topic is for class 11th, that is uh, a relationship among the various physical quantities, which is the third application of dimensional analysis. We have already discussed the first two applications of dimensional analysis, and we have already solved some numerical problems on the basis of first two applications of dimensional analysis. Today we will discuss the third application, that is the relationship among various physical quantities. We can derive the relationship among the various physical quantities by using the principle of homogeneity of dimensions. If we know the various factors upon which the physical quantity depends, then we can establish the relationship among the various physical quantities. Now, today we will apply with this relationship, this third application, in this question, in this numerical, which is very important numerical. So that is to dimensionally derive dimensionally the expression for the centripetal force which acts on a particle having mass m moving with the velocity v and in a circle of radius r. So that means the particle is moving in a circle having radius r, mass m and velocity v. So first of all, we should know what is the centripetal force. We have already discussed the centripetal force. The centripetal force is the force. It is the force which deviates the linear path of the body into its circular path and is directly radially inwards in to the circular path. So this, as far as this numerical is concerned, the centripetal force, which is denoted by F, that depends upon, means that is directly proportional to the mass of the particle, which moves in a circular path, and it also moves with some velocity. That velocity we represents by a v, and it also depends upon the radius. They say in the figure, it's mentioned here, centripetal force of a particle depends upon mass, velocity and radius. Or we can write here. So we'll write here A, B and C. Now A, B and C, these are the dimensions of mass, velocity and R. Or we can write F is equal to K, M raised to power A, V raised to power B, R raised to power C. While this K, this is the dimensionless constant. Here is the dimensionless constant. You can write here K is a dimensionless constant. Dimensionless constant. And A, B, C or the A, B and C are the dimensions of mass, velocity and a radius. Dimensions of mass, velocity and a radius. Now first of all, we will write the dimension formula of each physical quantity which is involved in this physical relation. Here we have force, we have mass, we have velocity and we have a radius. So we have already derived the number of dimensional formulas. We'll directly write here F is equal to the dimension formula of force. We know that the dimension formula of force, that is m1 L1 t raised to power minus 2. So this is the dimension formula of force. Similarly, we have the dimension formula of mass. Dimension formula of mass, or we can write here small m, dimension formula of mass, that is m1 L0 t0. So it's a dimension formula of mass. Similarly, we have here velocity. We'll write the velocity of dimension formula of velocity, that is L divided by t. That's a displacement divided by time. So that will be equal to m0. So mass is absent. L1 or t raised to power minus 1. That's the dimension formula of velocity. Then we have radius r. R means that's the length. We can write it as m naught L1 t raised to power t naught. Sorry, it's t naught. T naught. Now we have to apply the principle of homogeneity. So we'll substitute the value of force, mass, velocity, and R in equation first. So this will be the equation first. Equation first. So equation first, that is F. Equation first, I will write it again. F is equal to K M raised to power A or V raised to power B R raised to power C. So here K is the dimensionless constant. We can write here the dimensions of force. Dimensions of force are M1, L1, T raised to power minus 2. So dimensions of force is equal to, so K is dimensionless constant. Here the dimensions of mass. So dimensions of mass are M1, L0, T naught raised to power A. Dimensions of velocity. We have the dimension of velocity here. So M0, it's M0, L1, T raised to power minus 1, but raised to power B. Similarly, we have dimensions of R. We'll write here M0, L1, T raised to power 0, but whole raised to power C. Now we will apply the principle of homogeneity. We can derive the expression for the various physical relations by using the principle of homogeneity. So here we will write M1, L1 or T raised to power minus 2, that is equal to, so during the multiplication we will write here M1, but it is raised to power A, so this will be, here it's M1, M0, M0, but it will be equal to here M1 raised to power A, so it will be M raised to power A. Similarly, we will write here L0 here it's L0, it's L1, it's L1, but it's L raised to power B, L raised to power C. So we will write here L raised to power B plus C, B plus C. Similarly, T raised to power minus B, here it's T raised to power 0, here it's T raised to power 0. So we can write here it is T raised to power minus B, T raised to power minus B. So it's M0, M0. So it will be called M raised to power 1, 4 raised to power A. So it's M raised to power A. So here it is L0, L1, L1. So it will be called L raised to power B plus L raised to power C. So here it is T raised to power 0 or T raised to power minus 1, T raised to power 0. So it will be equal to T raised to power minus B. Now we will compare the coefficients. We will compare the powers of the fundamental units. Comparing the powers of the fundamental units. So we have fundamental units here: mass, length, and time. Here, so first of all, we will compare the powers of mass. So compares the powers of. So first of all, we will compare the powers of mass. So here, power of mass, that's 1 is equal to, here it's A. So we'll write here A is equal to 1. So the value of A. Then we will compare the powers of length. So it's equation first, or we can say it's equation. So equation first is this. We'll write it equation second. This is equation second. Then we will compare the power of length. Powers of length. So here the power of length is 1 is equal to, the power of length is B plus C. Or we can write here B plus C equal to 1. So this will be equation second equation. Then we have the powers of time. Here power of time is minus 2. Here it's minus B. So we'll write here power of time, that is power of time. So this will be equal to minus 2 is equal to power of time is here minus b. So minus and minus will cancel to each other. We'll write here b is equal to 2. So the value of b is 2. Here we'll substitute the value of b in equation second. Put the value of b. Put the value of b in equation second. Equation second. So here we have equation second is b plus c equal to 1. What is b? So b is here 2 plus c equal to 1. Or we can write here c is equal to 1 minus 2. C is equal to minus 1. So this is the value of c. Now we will substitute the value of a, b and c in this equation. In equation first. In equation first. Put the value of b. Put the value of a or b and c in equation first. So what's equation first? That is f is equal to k m raised to power a v raised to power b r raised to power c. So f is equal to k m raised to power a. What's a? So a is 1. We'll write here 1. Then we write v, velocity. What's the value of b? So that is 2. And r raised to power c. C is raised minus 1. C is minus 1. C is minus 1. Or we can write here f is equal to k m raised to power 1 v raised to power 2. And this r raised to power minus 1, I will write it as r. Or we can write here. So this is the expression for the centripetal force. F is equal to F is directly proportional to mv square divided by r. So this is the expression for the centripetal force. Similarly, so it was the first numerical. We can derive the expression for the second numerical. So numerical second आप लेंगे. So that is second numerical. Second numerical आप लेंगे. So I hope you will do it yourself. So फिर भी मैं आपको बताता हूँ. The numerical is, write down. The numerical is the pressure of a liquid column. Pressure of a liquid column depends upon the density of the liquid column. Density of the liquid column density of the liquid column. Number second, acceleration due to gravity. Acceleration due to gravity. Number third, height of the liquid column. Height of the liquid column. Establish a relationship among the various physical quantities. Among the various physical quantities. I hope you will do it yourself. Thanks.